This video, we're going to start looking at our unit circle. But before we get into the actual unit circle itself, we're going to talk about a couple of things that we've been looking at just to kind of bring it all together, because we're going to be using some of the stuff from the last few videos to make our unit circle. Now, I strongly recommend that you have a sheet of paper out so that you can write down the unit circle, because you don't have to memorize it, but you need to have access to actually see the unit circle so that we can use the unit circle. All right, so if you don't have anything to write on, pause real quick, go grab something to write on, and then when we get to the unit circle itself, we'll start getting to where you need to start writing some stuff down. All right, so to begin with, we've seen some special angles, right? Specifically with our special right triangles. So with our special right triangles, we have two kinds. All right, we've got a 30, 60, 90. And we have a 45, 45, 90. Right, so our special angles are actually going to have to do with the angles inside of our triangle. So like the 45 degrees, 90 degrees, 30, and 60. All right, and then that kind of leads us into drawing these angles and kind of graphing these angles. So for example, if I have an XY axis, right, we know that to have a right angle, right, you have the 90-degree angle, and if you could put your little box in there, and you have a 90-degree angles when your lines are perpendicular to each other, which we know the X and the Y axis are perpendicular. So I know that 90 degrees is in like my first quadrant here. This is 90 degrees. Each quadrant is 90 degrees. So what we're going to end up looking at is only quadrant one, because it ends up repeating itself for each quadrant. All right. If I wanted 45 degrees, 45 is half of 90. So 45 is right in the middle of that quadrant. So there's our 45-degree angle, and that starts from the bottom of the x-axis and goes up to 45 degrees. So the way that we graph angles, right, is we consider that our positive x-axis here is 0 degrees. That's where we start, right? And then if I go all the way up to the top, I'm at 90, right? And then I can keep going. Another 90 degrees would put me at 180. Another 90 degrees would put me at 270, and another 90 degrees puts me at 360, right? So if I go all the way around in a circle, so to speak, I go 360 degrees. All right, so if I keep going, your 30-degree angle is going to be smaller. So the way that I would actually graph 30 degrees is I would draw an XY axis, and I know it's got to be less than 45. Specifically, 30 is 1/3 of 90. So I can go about 1/3 into that quadrant and draw an arrow coming from 0 to that line, to that ray that I'm drawing, and that's representing 30 degrees. All right, if I wanted to do 60 degrees, 60 is twice 30. So if I draw an XY axis, I can try to go up another 30, but remember, it's got to be more than 45, so more than half, and then draw an arrow, and there's my 60-degree angle. You can do this sketching any angle that we want to sketch. So for example, if I wanted 200 degrees, all right, 200, there's not really anything special about 200, but if I wanted 200 degrees, okay, if I go back to what we said here, we're at 0, 90, 180, 270, 360. 200 is more than 180, but less than 270, right? So that means it's going to be down here in quadrant 3. Just to review, we have quadrant 1, quadrant 2, 3, and 4, right? C shape. So that's going to be down here in quadrant 3, all right? And then 200 is 20 degrees more than 180. So that means if I start rotating around, I'm going to get to 180 and have to go 20 degrees more, right? So if I were going to estimate where that is, I could draw it maybe there. It's about 20 degrees more, maybe give or take. But I start at 0, I go all the way around to 200 degrees. All right. But then what if I wanted to graph, let's say 400 degrees? All right, well, if I start at 0, right, I can go up to 90, then to 180, then to 270, then to 360, but 360 is still less than 400, right? So you have to imagine going around again or more, right? So 400 is 40 degrees past 360. All right, so that means that if I were to go all the way to 360, I would need to go another 40 degrees, which is right about there. But I don't go from 0 to that line to get 400 degrees. If I went from 0 to that line, that's going from 0 to 40, so that's only a 40-degree angle. So the way that we show that it's 400 degrees is we start at 0 and we do a swirl, because we go all the way around to 360 and then 40 degrees more. So you have a little swirl in there that tells you that you're not at 40 degrees, but you're actually at 400 degrees. All right. We can also have negative angles, right? So I might have a negative 45 degrees. So there's my XY axis. Well, positive 45 degrees starts at 0 and goes up halfway, like we put our green line up here, right? So there's my positive 45 degrees, but my negative 45 degrees starts at 0, and instead of going positive, instead of going up, we go down. So negative 45 degrees is going to be right in the middle of quadrant 4, and I'm going to draw my arrow going down. So this is how we visualize angles on our XY coordinate plane, right? So we have our 0 degrees, and we're going to go up and around, right? Or if it's a negative, we go down and around, and we can keep going around and around and around and around as many times as we need to. All right, so there's kind of the gist of our angles. We also want to review our 6 trig functions that we've seen in our last video. All right, so we know the normal ones where we have our SOHCAHTOA, sine, cosine, and tangent. All right, and you have to have that memorized. So we've got sine, and we're just going to use theta as my variable. So sine of this angle theta is going to be our opposite over the hypotenuse. So the opposite side over the hypotenuse. Cosine of theta is going to be the adjacent side over the hypotenuse. And tangent of theta is going to be the opposite side over the adjacent side. All right, SOHCAHTOA, that's hopefully old news stuff that we've seen before. All right, the new stuff that we added are other 3 trig functions that go along with sine, cosine, and tangent. All right, and that's our cosecant, right, which we put with CSC, secant, and cotangent. All right, everything needs a co, so you've got to make sure you know which ones match up. Right, so that means sine doesn't have a co in it right now, so it's going to go with cosecant because it needs a co. Cosine already has a co, so it's going to go with secant. Right, and then tangent needs a co, so it's going to go with cotangent. All right, and then to figure these out, you got to go back to SOHCAHTOA, right? Because cosecant, right, is like the reciprocal for sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Secant's the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant is going to be hypotenuse over adjacent. All right, and then cotangent's the reciprocal for tangent. So cotangent is going to be adjacent over opposite. So you've got to know SOHCAHTOA in order to know your other 3 trig functions, right? And this is going to be important, right, when we start using our unit circle to find these values of our special angles. All right, so there's our 6 trig functions. All right, now you need your pen and your paper. We're going to fill in our unit circle. Okay, so here's our unit circle. The reason that we call it a unit circle is because the radius is one unit. Right, so our radius is 1, and we've got 3 lines in each quadrant, right? Those 3 lines are our special angles, right? So our first one's a 30 degrees, then the 45 degrees, then the 60 degrees, and then that pattern continues in all 3 quadrants. All right, and again, you don't have to memorize this. You do have to have it written down somewhere, though, so that you can use it when you start answering questions. All right, so to start with, I'm going to fill in all of our degrees. All right, so I'm going to put my degrees in the solid blanks here going around. And remember, we start at 0 degrees. Well, then my first angle that I come to out of those special angles we were looking at is 30 degrees. All right, then my next one is 45. The next one is 60. And then I'm up at 90. So there's our first quadrant. Then we're just going to keep counting around in degrees, right? Just like we did before, we said this was 90 degrees. So if I go another right angle, another 90 degrees, that's going to put me at 180 degrees. And then if I go another 90 degrees, 180 plus 90 is 270. And then another 90 degrees gets me back to 360. All right, well, my first line that we come to is just like the 30-degree line here. So that means I went 0 plus 30 to get to the 30 degrees. So to get to my first line here, I can take 90 plus 30 degrees because this angle here is the same 30 degrees as the 30 degrees here in terms of that quadrant. So 90 plus 30 is 120. All right, well, the middle one's 45. So 90 plus 45 is 135. Then my third one is the 60, so 90 plus 60 is 150. All right, so there's quadrants 1 and 2, all of our special angles. All right, and then if we keep going, same concept. My first one's a 30 degrees, so 180 plus 30 is 210. 180 plus 45 is 225. 180 plus 60, 240. And then we got our 270. So here's our third quadrant. And one more time, 270 plus 30, 300. 270 plus 45, 315. And 270 plus 60 gets us to 330. So here's all of our angles, all of our special angles, all the way around our unit circle. All right, and again, we could keep going, right? If I wanted to be more than 360, I would go all the way around plus some. All right, and we'll get into something we'll talk about in a second there. Okay, but so here's all of my degrees. All right, the next thing we're going to add in there, right, which is this dotted line, that's going to be our radiance. Now, we talked about going from radians to degrees and degrees to radians. So if I want to take degrees and get to radians, I take whatever the degrees is times pi over 180. Right? Because I want my degrees to cancel. So I have the degrees that'll cancel with the degrees down here, and then you just simplify. Right? So that's how we get to radians. All right, so we're going to do that a couple times here, and then we're going to look at our patterns and go around. All right, so for example, the first one, easy one, let me switch colors here. 0 degrees, 0 times anything is 0, so that's 0 radians. All right, now we're going to start doing this, and I'm going to give you the shortcuts, but if I have 30 degrees, right, 30 times pi over 180, right, my degrees cancel, right, trailing zeros cancel, so that starts to simplify to 3 pi over 18, which if we keep going, becomes pi over 6. So 30 degrees is pi over 6 radians. All right, but another way of looking at it, see, I'm going to try yellow to see if this works good, but 180 degrees is equivalent to pi radians. Right? That's our big like equivalence right there. So 180 degrees is equal to pi radians, right? Which means I can go ahead over here to 180 degrees and put a pi. All right. So then if you look at this in terms of like pieces of your unit circle pie going on over here, right? I got a piece of cake or a piece of pizza, right? If half of this circle is pi, right? That means that the whole circle is going to be 2 pi. All right. Then if I have half the circle's pi, a quarter of the circle is going to be half of half the circle, or half of pi, which is just pi over 2. And then I can cut in half again. Half of pi over 2 is going to be this middle line here, right? Cutting that quadrant in half. So half of pi over 2 is pi over 4. All right. Then if you look at this bottom one down here, right? I went from, well, we'll do the 60 degrees first, right? We said 60 degrees is double the 30 degrees. So that means my radian is going to be double pi over 6. So pi over 6 times 2, right? It simplifies to pi over 3. Right? Then it's just a pattern. Then it's just a matter of plugging in, right? So like if I have 1 pi over 6, this is 2 pi over 6, 3 pi over 6, and I can count up by 30s, right? And then I can count up by pi over 4s, right? I can count up by pi over 2s and just fill in the rest, okay? And again, I'm not worried about you necessarily being able to find these as much as it's you need to be able to recognize where they are in the unit circle. All right, so I'm going to go ahead and start filling this in quickly, and it's okay if you're not 100% sure on how I'm filling it in. Okay, the biggest thing is once we have all this unit circle filled in, you're able to use it. Okay, so I'm going to start by counting with pi over 2's. So I have 1 pi over 2 for my 90 degrees. I have 2 pi over 2, and then I have 3 pi over 2. Then I'm going to go with my 45s. So I have 1/4, 2/4, and then over here, 3 pi over 4, 4/4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4 simplifies. All right, and all I'm doing is simplifying my fractions. Okay, then I'm going to go with we'll go with pi over 3's, right? So there's 1 pi over 3, and then if I go another 60 degrees, I'm at 120. So that's 2 pi over 3, right? Then I'm at 180, which is pi. So that's 3 pi over 3. Another 60 degrees is 240. So there's my 4 pi over 3. And then another 60 degrees gets me at 300, 5 pi over 3. Right? And then 6 pi over 3 is 2 pi. Then if I go with pi over 6, I have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Here's 1, 5 pi over 6. 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and our last one, 11 pi over 6. Again, I'm not super stressed about you being able to, fill this in. You're just going to have to be able to use it. So then the blue, we have degrees, right? And then in the red, we have radians. They're the same thing. It's just 2 different units of measures. All right. And now the fun part. Now we're going to figure out what these actual ordered pairs are, because the ordered pairs are what we're going to use to actually figure out our exact values. So let me change colors. Let's see. I'm going to go with pink. All right. So for our values here, some of the easy ones, like the ones that are on the X and Y axis. For example, this ordered pair over here at 0 degrees. That is on the X axis, and because this is a unit circle, I'm going over 1 unit. So that ordered pair is 1, 0. right? If I go to the left to 180 degrees, right, I'm going to -1, 0, right? And then if I go up 1 on the y-axis, my x is 0, y is 1. And then down 1, x is 0, y is -1. So those are my ordered pairs for those 4 points. Those are the easy ones to get to, right? Because it's on the x and y axis. The rest of them actually come from our special right triangles. Okay, and again, what I'm writing over here on my unit circle, this is the important stuff that you've got to make sure you have written down somewhere so that you can answer questions quickly just by reverting to the unit circle and coming back to it to read it, right? And we'll talk about reading it later, but right now we're just worrying about filling it in. All right, so all right, if I talk about, well, I don't even want to draw it that way. Uh-oh. Okay, what we're going to work on right now is filling in my ordered pairs, right? So like this ordered pair here is going to be an x comma y, right? That has to go over x and up y units. So to figure out the x's and the y units, I'm going to draw a right triangle, right? Because I know the bottom is the x, I have to go over the x units and up y units to get to this point, xy. Right, well, because this is a unit circle, my radius is 1, this hypotenuse of my right triangle is a radius because it goes from the center to the outside. That's a 1. All right, so I'm going to take this triangle and get it out of my way here. Slowly. All right, and I'm going to redraw it on this side. Try to redraw it. This is a mess of a triangle. All right, we said this was x, this was y, and my radius was 1. All right, well, this angle right here is my 30-degree angle. So I'm going to put 30 here. And then I'm going to put 60 over here because it's a 30, 60, 90 triangle. All right, well, for 30, 60, 90, I'm given the hypotenuse. Here's my short leg, y. So to go from my hypotenuse to short leg, we divide by 2. Right, and then to go from short to long, we multiply by √3. And I can rewrite that 1 times √3 is just √3. So I can write that as √3 over 2. So that means that I can make my ordered pair the x comma y. So this ordered pair right here is going to be √3 over 2 because that's the x, that's how far I go over, and then 1/2 going up. All right, so all of these values that I'm about to write in come from our special right triangles, and it's just a matter of looking at the ratio for your special right triangles, right? Like this one's a 45, 45, 90, which means I know that x and y have to be the same. And so that's going to be √2 over 2, comma √2 over 2. All right. And then a cheat, just to help us a little bit. 30 and 60 come from the same triangle, right? But like if I were to rotate this around to where the 60 was down here and the 30 was up top, that means that my x's and my y's switch. So this ordered pair ends up being 1/2 √3 over 2. All right, and that's the gist. Okay, the rest of it is going to be the same ratios going around. It's just going to be changing our signs, right? So the easiest one to work with is the one where they're the same, right? √2 over 2 and √2 over 2. Every 45-degree spot in each quadrant is going to have to do with √2 over 2. But if I come over here in quadrant 2, well, in quadrant 2, I'm on the left side of my coordinate, all right, of my coordinate plane over here. So I'm in the negative x's. So that means that this one, instead of being √2 over 2, comma √2 over 2, it's going to be a negative x. So negative √2 over 2, positive √2 over 2. Then if I come down here in quadrant 3, I have negative x and negative y. So both of them are negative. And then in quadrant 4, I'm in the positive x's on the right side for the x's, but on the bottom for the y's. So that means I have a positive √2 over 2 and then a negative √2 over 2. All right. Then it's just a matter of filling in the rest. So one way of, or another way of looking at it, giving you kind of a lot of hints here, is that this point over here is a reflection of this point over here. So it's going to be the same x, y, except the x is going to be negative because I'm in the second quadrant. In the second quadrant, x is always negative. So this is negative 1/2 and then positive √3/2. All right, then we switch, right, because the 30s and the 60s go together. It's just, switch the x's and the y's, but x still stays negative, so that's a negative √3/2, positive 1/2 at that point. Right, then I can reflect this point down here, right? So I'm going to keep it the same, but now on this quadrant, both x and y are negative. And then I can flip them. All right, and then over here I can reflect that one over, but now the x is positive, so it's a positive 1/2. All right, and then up here, flip it, but keep the x positive. So we have positive √3/2, negative 1/2. All right, and that's our unit circle. Okay, again, in our class, I'm not requiring you to have this memorized. You'll have access to the unit circles, assuming you write it down. All right, and so you need to have your radians, you need to have your degrees, and you need to have all of the ordered pairs for all of these special angles all the way around our unit circle. Okay, the types of questions you're going to see to go along with this lesson, right? It's just a matter of locating points on your unit circle. So you might have a question about, it'll tell you you're at 135 degrees. Okay, so here's your angle. So that means you're working with this segment here. Oh, wow, that's a mess. All right, and it'll say, what's the x value? So you got to be able to look at your unit circle, find 135 degrees, and then you'll tell me it's negative √2/2. All right, or maybe it says that it's negative 45 degrees. Remember, negative 45 degrees means that you start at 0, but you go down 45 degrees, and it wants to know the y value. So it'll be negative √2/2. All right, and another shortcut just to cheat for how you can figure out negative angles using your unit circle, if you're not positive of where to go, find the positive value. So like if I wanted, let me draw it over here. If I wanted a negative 225 degrees, that one's kind of tough, especially if you're not used to the unit circle, you can't just quickly find negative 225. So what you can do is find positive 225 and then reflect it over the x-axis. So if I start at 0 and go to positive 25, that's going to be, 225, that's going to be down here. So here's my positive 225. All right, so then I'm going to take that and reflect it up. So here's negative 225. It's the same as 150. All right, these angles that are the same is actually something we call a coterminal angle. All right, which we're not going to focus on right now since, our semester's kind of crazy and everything because of, COVID. All right, but coterminal angles are angles of different numerical values that are at the same spot on the unit circle, right? So negative 45 degrees that we just drew here is coterminal with 315 degrees, right? And again, that's not a big thing. The biggest thing I want you to get from this video, which I know is a lot, right? It's a little overload, is I want you to have this unit circle written down with your radians, your degrees, and all of the ordered pairs, right? And these lines in there, because I want to make sure that you can locate each of these degrees or radians, right? And figure out the x or the y by looking at your unit circle. All right, and that's it for this part. This is our, round 1 of the unit circle. And our next lesson, we'll actually learn how to use this in terms of our trig functions. But right now, we just got to get used to the unit circle itself.